All right, like I said, I'm back. We're going to take a look at station number 6 from our review. And in this case, we're going to use our Taylor polynomial. There it is right there. This is the most famous formula for the rest of your life. It says the nth derivative at c. To generate a Taylor polynomial, it's the nth derivative at c divided by that derivative factorial x minus c to the n. Remember the following. The nth of c, this is the derivative at the center. And n is, of course, which derivative we're taking. And c is what we call the center. So we want to write a third degree Taylor polynomial for sine of 2x. So we need three derivatives, starting with f0, that's the original function, which is sine of 2x. The first derivative would just be 2 cosine of 2x. Our second derivative would become negative 4 sine of 2x. Don't forget, when I'm using how many that 2 and 4 is I'm using chain rule. And our third derivative would be negative 8 cosine of 2x. And now we want to find the value at the center. Remember, this is a Maclaurin series, so that we know that the center has to be 0. So the value of our zeroth derivative 0, which is just sine of 0 in this case, would be 0. Our first derivative 0, cosine of 0 is 2, times 2 is just 2. And of course, our second derivative at 0, its sign again would be 0. And the value of our third derivative at 0 would be negative 8. Remember, all I'm doing is I'm plugging in 0 in for my x. Cosine of 0 is 1 times negative 8. So to write my Taylor polynomial, we would go p sub 3 of x. Remember, that 3 right there is going to be our degree, the number of derivatives for us. This is going to equal, ready? When we set this up, n equals 0. Well, that was just 0, so we didn't worry about that. N equals 1. My value of my derivative, remember, I'm just going to plug it in here. This is going to be 2, whoops, sorry, 2 over 1 factorial, x minus my center, 0, to the first, plus let n be 2, which is 0. And if I let n be, oops, n be 2, that's what we're looking to, 3, that's going to give us minus 8 over 3 factorial x minus 0 cubed. Now you can leave it like this. There'd be a plus there. Oop, and all right, that'd be a plus there. Sorry about that. And all right, because we're adding them all. Now, so when I get my final answer here, we can simplify this. P sub 3 of x. This is just going to be 2 over 1 factorial, just x to the first, minus 8 over 3 factorial, x cubed. And that would be our polynomial. You can clean this up a little bit more by just saying it's just 2x minus 8 over 3 factorial x cubed. And that would be our Taylor polynomial. The next question says, okay, let's use part A to approximate the value at 1. So just get P3, plug in the point 1. This is like saying, okay, the sine of 2 times point 1, 2 times point 1 is about the value. We're just trying to approximate. In other words, this is just the sine of point 2 is what we're trying to approximate here. I don't know it offhand, but I can just plug it in. This becomes 2 times point 1 minus 8 over 3 factorial times point 1 cubed. And there is our approximation. The last question says, okay, use your answer to approximate the sine of 2x dx. Now, I know I could integrate this one, but it says use our answer, so we're just going to substitute in. So this just becomes from 0 to 1, 2x minus 8 over 3 cubed, x cubed, dx. Please don't forget your dx's. And this is going to equal, integrating it, x squared. Be careful because it goes x, this becomes 2x squared over 2, minus 8x to the fourth over 4 times 3 factorial from 0 to 1. Using the FTC, f of 1 minus f of 0. Plugging in the 1, we just get 1 minus 8 over 4 times 3 factorial. And everything there has an x, so that whole last term is just 0. So there's our approximation. It's not the exact value, but how accurate is it? We can actually use the alternating series error to get us how accurate that is, and which you might have to do in your test tomorrow. Hint, hint. I don't know. We'll see. We'll see. All right. So the important thing to remember is just be able to use this term right here. All right. Another way we can use it, example number 3 here we saw, given the Taylor polynomial centered on x equals 3, used to approximate f. So we want to find the value of the third derivative. That's really what this is saying. We're saying here n is 3. So that is the value of the third derivative. And because this is a Taylor, we're going to use our Taylor rule. Fn of c over n factorial x minus c to the n. Now, since I'm only looking for the first part, if I go back up to my Taylor, I'm only looking for this part right here. I really don't need the center part. So what I'm going to do is I'm going to generate the coefficient. So to generate the coefficient, we're going to use all this, our coefficient. So to generate it, it's going to be f3 of c, my center is 3, over 3 factorial. And I find out, well, which term here represents the third derivative? It's the one that has a power of 3. And if I look at the coefficient, be careful, it's a negative 1/4. So this is going to equal negative 1/4. And just do a little bit of algebra. We're going to get negative 1/4 times 3 factorial, whatever that is. That's the value of our third derivative. Kind of a jerky problem, if you ask me. All right, for part 2, I'm going to set this up right here. This is the same thing. It's all Taylor. So if you look at your Taylor polynomial, there's my rule. It says the function f has a Taylor centered around x equals negative 2. And we know that the value of the nth derivative, that's what it's telling me, this is the value of the nth derivative. And they want to write a fourth degree Taylor polynomial around 4. So we know we need 4 derivatives. So if I let f0 at negative 2, I'm just going to use our rule. What they're telling us is the top part. That's the top part right there. And to get it, it's just going to be 1 over 3 times 0, which is 0, plus 1. So my first value is 1. 1. 1 at negative 1. The value of the first derivative becomes 1 over 3 times 1, which is 3, plus 1, which is 4. The value of our second derivative at the center is going to be 1 over, that becomes 7. And the value of the third derivative becomes 1 over, that becomes 9 or 10. And the value of the fourth derivative, ran out of room there. Again, if I plug it in, this is 1 over 3 times 4 plus 1, which is 1 over 13. Sorry about that, 1 over 13. And I want to write my fourth degree Taylor, so I'm going to set up my notation, is, let n be 0, 1 over 0 factorial. So now I'm going to build my Taylor here. Now I'm building up my Taylor, 1 over 0 factorial, x minus my center to the 0, plus 1 over 4 over 1 factorial, x minus 2. Whoops, sorry, we're centered at negative 2. I messed up there. We're centered at negative 2. So these should really be pluses to the first. The next one, plus 1 over 7 over 2 factorial, x plus 2 squared, plus, keep going, 1 over 10 over 3 factorial, x plus 2 cubed, and then the last one, plus 1 over 13 over 4 factorial, x plus 2 to the fourth. And of course, you can rewrite this if you want to simplify. This is just 1 plus 1 over 4 times 1 factorial, x plus 2 to the first, plus 1 over 7 times 2 factorial, x plus 2 squared, plus 1 over 10 times 3 factorial, x plus 2 cubed, and then the last one, of course, being plus 1 over 13 times 4 factorial, x plus 2 to the fourth. And that would be our Taylor, as simplified as we want to get it. Hope you all enjoyed the video. Smash that like button. I'll see you later. Bye-bye.